Hello, Ken, New Tech Inventors. I was just on the computer here looking at some of the comments and trying to answer some of the comments on the last video that I finally got out there to you guys. And a couple of people sounds like, are getting some 3D printers and getting into 3D printing. And that was one of the purposes of me having this channel, was to try to encourage people to get a 3D printer, learn how to do 3D CAD software and so forth. And one of the motivating factors that I used was the fact that here, an old guy, I was 73 years old when I started 3D printing. Up until that time, I had no experience, knew nothing about it. I hadn't even seen a 3D printer operate before that. So the fact is, anybody, I believe, can do it. And the next factor is, okay, people will say, well, how do you get into 3D printing? You know, that sounds like an expensive hobby or an expensive business to get started in. Well, not so. If you go back and look at some of my earlier videos, I talked about the different printers that I was using. I used a bunch of these little Monoprice Delta printers, and I had a lot of the King Runes, and I started out with different types of printers. But then as I went along and started creating a business and had parts that I needed to produce and sell on the website and so forth, and even making parts for customers locally and around the country. As a matter of fact, I found out that I had to be able to print in volume. So I needed more printers, and hence I created the print farm. And I know when the term first came out, I just thought I had a bunch of printers, and I heard people using the term print farm and thought, well, okay, that makes sense. Having a farm and a lot of printers out there like dairy cows producing a product. Well, the printers that I started out with were less expensive printers. I didn't have a lot of money to put into it, and I didn't know if it was going to be a hobby or some fad or whatever. But I found out when I got into it that you could do a lot with them, and it encouraged me to build on that. And as you look back in the old videos, you'll see where I started the print farm down at the other building. And I think we started with 24 printers down there, ANETs. We had 8 ANET ET4s, 8 ANET ET4X printers, and 8 ANET ET4 Pro printers. And they were all on one wall in a rack. And they're still down there. Those same printers are sitting there, and they're printing right now as we speak. So, or at least several of them are. And I had to learn how to print parts in volume because I needed to make a lot of parts. The first step was, you don't just print one at a time on a printer. You print several at a time. And my philosophy was, I want the printers to do the work instead of Ken doing the work. Let the printers do the work. And by that I mean, instead of me spending a lot of time, I should be able to have these printers set up so that when I want to make some parts, all I have to do is just go down there and put some filament on a printer, select the job I want to run, and press go. And let it do the printing, and then I come back up here and I watch TV or eat dinner or do whatever I want to do, and then the next day I go down there and voila, the printers have printed all of these parts for me. So all I have to do is just rake them right off the bed, which brings me to another point. In one of the comments that I had, I think the comment was 220 degrees is too high for PLA. I print at 195 and get good prints. Okay, that was a good statement and it was fair. And I'm going to show you what my response was then to that. PLA is way high at 220. I run wonderful parts at 195. Okay, my reply to that was, I've also printed good parts with PLA at 195 to 200 degrees, which is true. However, when I'm printing with a 0.6 or 0.8 millimeter nozzle and at high speed settings on the printer and in the slicer software, I'm pushing more than double the normal filament through the nozzle than what you would have with the standard printer settings and a standard 0.4 millimeter nozzle. So what you have to remember is that you're wanting filament to flow freely, so you have to be able to heat it to a temperature, and when you're pushing twice as much filament through that nozzle, it is going to take more heat to heat up that filament. It just makes sense. And then when it comes out of the nozzle, what is the temperature of that filament? Okay, if you set your hot end at 195 degrees and you're pushing more than twice as much filament through there at 195 degrees, that filament coming out of the end of the nozzle, that melted filament, what temperature is it going to be at? 170, 175, whatever. At that temperature, if it's too cool, it's not going to adhere to the previous layer. It's going to lay down a little thread there, but that thread is going to be laying on top of the other. It's not going to be hot enough to fuse to the previous layer. So you're going to have a part that's not very strong. And if you want to see this happen, then you can set a printer up, and I did this accidentally early on. I had settings out of whack, and I printed some parts that would just come off like a croissant or something, different layers flaking off. The layers weren't sticking to each other, and that's because there wasn't enough temperature there and heat to cause those to fuse. So when you're using especially 0.6 or 0.8 millimeter nozzles, you're printing a whole lot faster. You're cranking those parts out in record time. I can run a whole roll or a whole kilogram of filament through a printer in about 20 hours or less sometimes. And when you're running that much filament in that short a period of time through your printer and through your hot end and out your nozzle, you want to make sure that it's laying down a bead that's going to be hot enough to fuse and make that part strong. And those parts that I was using as an example in the last video, they're printed with a 0.6 millimeter nozzle. So they're still printing a whole lot faster than you would with something like a 0.4. So that's the way I would answer that question or explain that. You've got to remember, just because it can print a part, it doesn't necessarily mean that that part is as strong as it can be. And a lot of times you look for strength. And when I look for strength, I try to do the best I can to get as much strength out of PLA as I can. If I can't get it there, then I'll go to PETG. If I can't get it out of PETG, then I'll go to ABS or something else. PLA is a very common filament. It does pretty good. The only thing is, I guess my parts are about 50-50, PLA and PETG, because any part that I print that's going to be exposed to extreme stress or extreme heat. Good example are the outdoor parts that I print. I mentioned I was into RV, doing some RVing now, and I'm printed a lot and made a lot of parts from our RV, and one of them were camera mounts for the outside of the RV, for outside cameras down each side of the RV, so that when I'm making sharp turns I can still see the rear down the sides of each side of the RV. And those mounts have to be pretty weather resistant. They've got to be able to handle the heat of the intense sunlight all the time. And another example is my gate coming onto my property. I have an electronic gate, and there's a push button station for UPS and FedEx and so forth, so they can come through the gate. They have to pull up and they push a code into that transmitter, and it was on a metal pole, and the metal pole was absorbing some of the radio frequency, and it wasn't transmitting very well to my gate operator receiver. So what I did was I built a standoff that went between the metal and the push button entry system, and it was about 3.5 inches thick that stood out, and it's out there in the sunlight all the time. So it had to be PETG. But again, even with PETG, I was printing those parts at like 145 degrees or something like that, which is pretty hot temperature. But again, I was using I think I was using probably a 0.6 millimeter nozzle with that also. That had to be pretty strong and durable, and it had to be able to withstand the heat and not warp or get soft or anything like temperatures out there now. We're in the 100+ degree temperatures here locally. The heat index and the actual temperatures are like about 98 degrees. That's pretty hot. And when you got direct sunlight on a sunny day, and these parts were printed black also, so, and you have a piece of black plastic out there, if it's PLA, it's probably not going to make it. PLA just can't handle that kind of heat in the direct sunlight, but PETG can do better. But even at that, those things have to have a certain density, and to get the density you have to make sure that each layer fuses to the previous layer. When that filament comes out of that nozzle, it better be over 200 degrees, or it's not going to be hot enough to melt into the previous layer that you laid down, and it's got to melt into it to fuse. So anyway, that's a little bit about that, and trying to answer these comments. Okay, another question on here was this one. Okay, hypothetically speaking, if you could print a single job 75% faster using a different printer, would you consider replacing printers to reduce the heat footprint? Okay. Yeah, I mean 75% faster is fast. Now, I'm already printing over 100% faster with the printers that I've got. The ANETs that I'm using, their normal speed is with the normal settings that come with the ANET ET4 printers and with a 0.4 millimeter nozzle. Okay, when I bump the nozzle up to a 0.6 or 0.8 on those printers, and I tweak the settings on the printer, then I can get that printer to where it's printing a whole lot faster. As long as it can handle the speed and handle the additional flow, then I don't know that there's another printer out there that would really be that much faster. Now, I am going to do a video because a lot of people are talking about getting into 3D printing. And so this video that I'm working on now, I've already made a couple short video clips I'm going to use in it. But I'm going to go out and I'm going to go online, I'm going to find a couple printers, and I'm going to find some filament, and I'm going to buy it, and I'm going to assemble the thing and get it printing and everything. and show you, videotape the whole thing and put it online and show you that I can get a printer, get the software and everything for under $200. And for under $200, I'm going to have two different examples. And I've already purchased the two printers that I'm using for that. I'll show you what's involved in assembling them, downloading the software that you need to do some 3D drawings and go through some simple stuff there. And you can do it for under $200. I guarantee you. You can go out there right now and I'll prove it, and get a printer and get the software and be doing some 3D printing and starting out just like I did in December of 2019 with my first printer. And these printers that I'm going to be using are a whole lot easier to assemble. They're partially assembled, so there's not a whole lot involved in assembling them. The first printer I had, it was pretty involved. It must have had, gosh, over 100 parts. The ones that they have now and the ones I'll be using as an example are going to be simpler, and I'm going to be buying the stuff on eBay so anybody can do it. Anyway, I wanted to show you a few of those comments that I'm getting, and some of them are motivating me to do some different videos to help different people that want to get started, and to help some people that have maybe already been doing some 3D printing and just haven't figured out yet how they can speed up their process. I know for a long time I was printing, and I had a lot of printers, so I needed 100 parts. I might have 20 printers. Each one of those 20 printers is going to have to print that part 5 different times. And if it was taking me 4 hours to print it, then I'd have to run all those printers for 4 hours, then take a part off, and then start them again, and take a part off and start them again. And then I learned that, okay, if I get a little larger printer, I can put 5 parts on each printer. And then if I have 5 parts on 20 printers, I can print them all in 4 hours and get 100 parts. And then I thought, okay, if I can print and get it to where it will print as good a quality part using a 0.6 or 0.8 millimeter nozzle, and maybe speeding the printer up a little bit and tweaking settings, I can print it in 2 hours. So now I'm getting my 100 parts in 2 hours off of 20 printers. So anyway, that's how it evolves. And I'm glad to show everybody it's pretty simple. One of the printers that I ordered actually came with some nozzles, and it had some 0.6 and 0.8 millimeter nozzles in there, I think. So that'll be good, because if somebody buys that printer off eBay and it's less than $150 and it's on there right now, we'll find out how well it does. And if it prints okay and passes some of my tests, then I'd recommend somebody starting out that is on a budget and wants to try it, go ahead and do it. $150 to $200, that's not chump change. That's still money, and at one time in my life that was a whole lot of money. But still, for some people, with the economy the way it is and everything else, you don't want to waste $150 to $200. But if you get into 3D printing, I don't think you're wasting your money. I think you'll find it rewarding, and a lot of people, once they figure it out and see what it can do, their little gears up here in the brain start turning, and they start figuring out ways to make money doing it. And before you know it, they'll be like me and have 60 or 70 printers down there in a room. Well, I guess that's enough for right now. I just wanted to kind of touch base very quickly, and then I'll be able to get this video out in the next few days that will show you how I went out and purchased a couple printers and downloaded the software and everything step by step, so that you can follow, do the exact same thing, and even help you a little bit with how to get started downloading and using a 3D CAD software package, which is what you'll need to create the 3D image and then export it to an XTL file. And we'll start out and do something pretty simple. But once you start doing it, you just need to practice. I learned I didn't have any help or training or anything. I just sat down and made a simple little square with a ball on top of it. It was my first print. And then I started going from there and being a little more creative. And then there are a lot of things you learn about. You can't just draw anything and expect a 3D printer to be able to print it. There are certain parameters. When we get to that point with the 3D software, I'll go through and show some examples of, go step by step through that to help anybody that wants to get started. And then hopefully it'll inspire a couple people out there that are kind of on the fence, having a hard time making a decision whether or not they want to spend some money, and then what do they buy. And I'll be able to give them an example of what they can go on eBay right now and buy, and it'll be in a few days, and I'll show you exactly what's involved. And you can use my video to show you how to put it together and how to download the software that you need, which is only going to be the CAD software, and you can download it free. I'll show you how to load up the printer and each step you go through to create the 3D image, and then export it as an STL file, and then copy that file into your slicer, and then once you get it in the slicer, copy it to a micro SD card, and then you plug that into your printer and start the printer up, get your settings right on the printer, and you're ready to go. So I hope you'll stick around for that video, and then after that, if that one goes well, then we'll find something else of interest and move on with that. So until the next time, thank you for watching, and happy printing.